Welcome back everyone. In this lecture, we are going to explore the next step in array structures, two-dimensional arrays or simply 2D arrays. These arrays allow us to store data in rows and columns, just like a table, spreadsheet, or even a chessboard. Let's see how they work. So, what is a 2D array? A 2D array is like a table made up of rows and columns. Let's look at an example. Suppose we have an array which have elements 10, 20, 30, 40, 50 and 60. The element at row 0, column 0 is 10. The element at row 1, column 2 is 60. We access them using two indices. Array row 0, column 0 gives us 10. Array row 1, column 2 gives us 60. So it's just like giving coordinates. First the row and then the column. Now let's see how we declare a 2D array. In most languages, we specify the number of rows and columns. For example, array of row 2 and column 3 means 2 rows and 3 columns. To calculate the total number of elements, we simply multiply rows and columns. 2 cross 3, that's equals to 6 elements in total. This makes 2D array more perfect for handling matrix data, mark sheets, and grid-based games. To access a value in a 2D array, we need two indices, one for the row and the second one for the column. The general syntax is array, then we have to write row and then column. For example, if array of row 1 and column 2 gives us 60, it means that the value 60 is stored at the second row and third column. Remember, indexing start from 0. To go through each element at a 2D array, we use nested loop. The outer loop goes through the rows, the inner loop goes through the columns. The general logic look like this. For each row, it is the outer loop for rows calculation and the inner loop for column calculation. And then we are printing arrays elements. This is how we can display or process all elements in a structured way. Now let's understand how 2D arrays are stored in memory. Although we visualize them as a matrix, in memory they stored as a single continuous block. There are two common ways of storing them. The first one is row measure order. Elements are stored row by row. This is the default in most programming language like C, C++ and Java. The second one is column measure order. Elements are stored column by column, used in some mathematical software. Let's take this example. Array of row 2 and column 3. The first block contains 10, 20 and 30 and the second block contains 40, 50 and 60. In row measure order, the memory store it like this: 10, 20, 30, 40, 50. So even though we see rows and columns, the system see it as a flat block of data. That's all for today's session on two-dimensional arrays. Now you understand how to declare, access, traverse, and even visualize their memory layout. In the next lecture, we will move on to explore more advanced topics like multi-dimensional arrays and sparse matrix, where things get even more interesting. Thank you for your attention. See you in the next one.